To run AI agents at scale, you eventually run into a physics problem disguised as a billing problem. Traditional cloud infrastructure breaks down under the weight of autonomous workloads. For decades, cloud computing was optimized for a simple, linear request-response cycle. A user clicks a button, a stateless server processes the request, sends a response back, and terminates the connection. This diagram compares a linear web request, left, with an AI agent looping, right. Standard containers force a nil environment for every step, creating cold start delays. Keeping containers warm eliminates this delay, but now you pay for idle time while the agent pauses. For latency-sensitive applications, this ruins the user experience. You lose on speed if you let the environment shut down, and you lose on compute costs if you force it to stay running. Legacy container architecture economically penalizes the continuous, state-dependent behavior that makes an AI agent useful in the first place. Cloudflare Dynamic Workers provide a different compute primitive built specifically for these stateful workflows. Instead of spinning up containers, Dynamic Workers rely on V8 isolates. This is the exact same engine powering Google Chrome browser tabs. By completely removing the container layer, isolates drop startup times to single-digit milliseconds. They boot up at the tail end of human perception. Cloudflare prices this architecture at a flat rate of 0.2 of a cent, 0.002, per unique worker loaded per day. You are no longer billed for individual compute seconds or continuous idle time. This flat daily rate pulls the infrastructure cost floor down, allowing developers to deploy complex agent capabilities without destroying their margins. Let's map this out on a real workload. Assume a user triggers an AI agent to run a competitive analysis by scraping 10 external sources, a task that takes exactly 45 seconds to finish. This chart tracks the execution timeline. On the top timeline for a traditional container, the system spends anywhere from 5 to 30 seconds just booting up. That red block is pure cold start overhead. Next, the green block shows where the agent actually runs the 45-second analysis. After completion, the container stays warm to handle the next potential request, leaving a long trail of yellow idle standby time. The SaaS founder is paying the full instance cost across all three phases. You pay while the system boots, you pay while it computes, and you pay while it waits. Now look at the dynamic worker timeline for the exact same 45-second task. The active execution block begins in milliseconds. The cold start penalty is bypassed entirely. Because isolates do not require a warm-up period, there is no idle tail. You only pay that flat daily rate. Removing startup overhead and idle padding also removes the requirement to calculate and pre-buy capacity buffers for traffic spikes. Container overhead imposes an artificial bottleneck that erases the profit margins of latency-sensitive agent products. To see exactly how the isolate mechanically achieves this high speed, we need to compare the underlying compute stacks. A container operates through heavy abstraction. It builds vertically from the hardware, up through a host operating system, a container engine, a guest operating system, your binaries, and finally, your application code. The V8 stack is much leaner. It goes from the hardware to the host OS, directly into the V8 engine, and then to the isolated execution environment. By bypassing the guest OS layer and the container engine entirely, the code executes instantly. There is no heavy operating system to provision or boot. Without OS-level provisioning tying down resources, the infrastructure can scale to millions of concurrent executions instantly without performance degradation. This speed requires a strict technical trade-off. V8 isolates run JavaScript and WebAssembly. They cannot support native Python binaries or heavy OS-level dependencies. But if your agent orchestration, API calls, and data workflows fit the WebAssembly constraint, the architectural speed advantage is absolute. This mechanical efficiency dictates how you build a SaaS financial model. Consider a scenario where a product experiences a surge in traffic, pushing 1,000 daily active users to trigger an analysis agent at the same time. This graph maps the financial impact. Under the legacy serverless model, you pay per invocation and per compute second. As the volume hits 1,000 invocations, the red line climbs sharply. Cloudflare bills base strictly on the deployed code existing in memory for that day. Whether that specific worker handles one request or 10,000 requests in a 24-hour window, the cost remains locked at that flat daily rate. As user adoption scales, the delta between linear container billing and flat isolate billing widens significantly. That gap is your captured margin. This effectively neutralizes the risk of a high-volume traffic spike generating an unpayable infrastructure bill. By finally utilizing the right compute primitive, you completely decouple high-volume agent usage from those linear compute costs. Infrastructure efficiency serves as a growth lever for product pricing strategy. Historically, high container costs forced founders to lock complex autonomous features behind expensive enterprise tiers. The unit economics could not survive lower price points. A predictable infrastructure cost floor creates the flexibility to rethink that packaging. When agents cost a fraction of a cent to execute, that analysis feature can be moved down the funnel into your middle or basic tiers. Offering these robust, autonomous capabilities to a wider user base is a primary driver for capturing total addressable market share. The infrastructure economics directly dictate a product's market viability. Cheaper execution buys you pricing leverage. Your immediate next step is to audit your current infrastructure logs, specifically for agent workloads. Measure the ratio of active compute time against the seconds burned on cold start overhead and idle padding. Systems with high startup to execution time ratios are the absolute most urgent candidates for an immediate migration to dynamic workers. Then, stress test your scale assumptions. Millions of concurrent executions no longer require you to pre-purchase capacity blocks. The artificial limits and timeouts that dictated how you broke up multi-step tasks in legacy serverless environments are no longer required. The container model made cloud computing broadly accessible. Utilizing V8 isolates makes autonomous computing economically viable at scale.